Hi students. In this video, we're going to define and discuss the difference between precision and accuracy. So accuracy refers to how close the measured value is to the actual value. You can kind of think of it as hitting the nail on the head, that expression. Another way of thinking of it is you can consider it as hitting the target right in the bullseye. So accuracy is how close you are to the target. Precision's a little bit different. Precision refers to how close a series of measurements are to one another. Basically, repeatability. Are you consistent? So you can have a situation where you throw darts and they're all very close to each other. This would be an example of precision. Why? They're all very close. So here I have data from several different students, students A, students B, and students C. And we can see they're all slightly different. So again, when we're looking at measurements, precision is if they are consistent with one another, okay? Accurate is if they're close to the actual value. So when I look at the true mass of an object being measured, and I could see it with this blue line right here, it would actually be, and based on this graph, we see that it goes to the tenths. So my, estimated guess or my doubtful digit would be between the tenths and go to the hundredths. So it looks like the true mass is 10.00 grams, okay? That's why when I look at all these values, I'm seeing them go to the hundredths place. Now, I want to actually further kind of analyze each of the students A, B, and C. So let's, again, to help us understand precision and accuracy, if we look at student A, they're all over the place, right? There's no consistency and they're never hitting the target. The true mass of 10.00 has not been hit at all. So this student is considered inaccurate and imprecise. Why could this occur? Well, one reason is random error. So what is random error? Random error could be, things that you don't have control of, right? Things that are impossible to eliminate, like variations in temperature. Maybe there's an air draft. Maybe the pressure is changing in the room dramatically. So you don't have control of all these things. So what can you do to minimize random error? Is you can do multiple trials and take an average. So when we look, the students all over the place, but we see that they took 4 trials. When we average the 4 trials, it's at least a little bit closer to the true mass. Again, the student is still inaccurate and imprecise, but taking multiple trials can help alleviate some of that random error. Now, what about student B? Well, student B seemed pretty consistent, right? But they never truly hit the mark. And we see that when we take the average, they're still off from the 10.00 grams. So this is probably due to what's referred to as systematic error, something that happens repeatedly. So systematic error could be due to poor technique, right? So one example is when you're reading the volume or measuring the volume, you're not looking at the bottom of the meniscus at eye level, or you're not dropping down to eye level and reading it. Another example is you could be using something that's not calibrated correctly. So maybe your scale hasn't been calibrated. Maybe the ruler you're using to measure length has a chip on the end. So that would be an example of a non-calibrated instrument. Or maybe this person was using different scales. They're not using the same scale on all. So all of this is systematic error, right? They're using an instrument that's not calibrated. They're using several instruments. So one of the ways you can do this is by practicing good technique and using the same measured, calibrated device, you can minimize systematic error. But again, this student is extremely precise. When I look at student C, they're both accurate and precise. So they probably have very little systematic error or random error. That's why they're both accurate and they're precise. So what you want to make sure to do is with all your measurements, you want to make sure that you wait if there is an error draft for it to stop, or if you're using an analytical balance, make sure you're always closing the caves. Make sure you wait for the instrument to stop moving, so the digits to stop moving around. And you're not applying pressure or anything like that. Basically, you want to use good technique and you want to use calibrated instruments and the same. So I hope this helps you understand the difference between precision and accuracy. And if you have any questions, leave them in the comment section or in the discussion board, or go ahead and send me an email. Thanks for tuning in.